welcome to this YouTube channel, IT on Demand. The last time I gave you an exercise to solve these problems, and so I just want to quickly go over these exercises before we continue with our video series. So the first one here is this 2 raised to power 2 plus 3. And if you remember how we said Python operates with using PEMDAS, and how that these operators are checked from left to right, depending on, so for instance, if you're working with multiplication and division or addition and subtraction, the order of operation between these two, multiplication and division, for instance, depends on how it's seen from left to right. So in this video, let's just solve this exercise. And if you look at it from the left to right, of course, I think the first thing we have to look at is, do we have parentheses? Because that's the first thing here. Looking at PEMDAS, the first thing is to ask ourselves, do we have parentheses? And the answer to that is no, there's no parentheses. And the next question is, do we have exponent? And yes, because this is the sign for an exponent, which of course means raised to power. So 2 raised to power 2 gets solved first. And 2 raised to power 2 is 4. And so we are left with 4 plus 3. And let me just copy this over so that we can see how we solve this, which is equal to 3. And of course, since we are left with just 2 operands and 1 operator, 4 plus 3 gives us 7. And let's just quickly check this using the Python terminal. And so here I will type Python. I believe by now you should know how to use the Python terminal, the terminal. So let's do 2 raised to power 2 plus 3. And this is the process I expected you to use in solving this problem. I don't want you to type it in Python before you solve it by hand. And the essence of this is just so that you can understand the flow of execution of these things. So most of the exercises that, some of the exercises would have at these preliminary stages, this is the idea I want you to inculcate. Try to solve them by hand before you solve them using the Python. So let's see if we get this correctly. And as you can see there, we have 7. So let's move over to the next one. The next one is this 2 plus 3 raised to power 2 plus 3 raised to power of parentheses 1 plus 2 raised to power divided by 3. And so the first thing, as you look at that formula, we have parentheses here. And so that'll be the first thing to solve. So let's write every other thing else and let's solve what we have in that parenthesis. In the parenthesis here, we have 1 plus 2. 1 plus 2 gives us 3, right? And that'll be 3 divided by 3. The next thing would be to look at these other expressions here. And what are we to solve next? So let's get back again to PEMDAS. We have P. We've already done that one. And we now have exponent. Do we have exponent in this expression? The answer is yes, we do. If you look at this is an exponent. And so let's solve for that first. So we have 2 plus 3 raised to power 3 is the same thing as 3 times 3 times 3. And that gives us 27. And so we have 27 here divided by 3. And we move again. Let's see, what do we have? Multiplication. Do we have any multiplication? No. Do we have any division? Yes, we do. If you look at this is division. And so we have 2 plus 27 divided by 3 would give us 9. And 2 plus 9 would give us 11. And so the answer we expect to get from these is 11. And let's confirm here using Python. So 2 plus 3 raised to power 1 plus 2 and divided by 3. Let's see what we have. And we have 11.0. And you might be wondering why we have 11.0. And I don't know if you've seen it, but I recently posted a short video, and I also created a poll, more like a quiz, just to indicate the difference between this forward slash, and which is called the true division, and the floor division, which is in this case. And so the reason we got the 11.0 here and not 11 is because, so let me just write this correctly. And the reason is that we have this true division. And when we use true division, it returns a floating type. And because Python has a very high support for floating types, when these types are mixed, so for instance, you have an integer here, but it's now mixed with a float, because 27 divided by 3 will give us 9.0. And with that, we have 2 plus 9.0. And because this floating point is highly supported in Python, it just does 11.0 rather than 11. And the difference is if we had this, our answer would have been 2 plus 9, and we would have had 11, which is an integer. And so I just want you to take note of that, just in case you see things like this. All right, so we have 11.0. Let's solve the third one, which of course is the last one. So let's solve this again together. The first thing is to ask ourselves, do we have parentheses? And definitely we do. And so let's solve for the parentheses. 2 plus 3 is inside the parentheses. We solve that, and that gives us 5. And let's have this raised to power. This 1 plus 2 divided by 3 is also in parentheses, but as you can see, we now have different things inside these parentheses. And so let's try to solve this. And this is a little bit tricky, and I didn't even notice this actually. So 1 plus 2 divided by 3 is what we want to solve now. 2 divided by 3. And take note that this is not a floor division. Again, I talked about this. And so 2 divided by 3 would give us 0. That'll be 20 divided by 3. 3 times 6, 18. So in this case, we have 0.667. I would just approximate that. That is what we get by doing 2 divided by 3. And if we have 1 plus there, and we do this, we close that parenthesis, and we do minus 4. And so let's complete this. We still have a parenthesis. And so we do 5 raised to power 1 plus that will give us 1.667. And we do minus 4. Of course, we do not need this parenthesis again since we've solved it. So this is where it becomes tricky, because I don't know what 5 raised to power 1.6667 is. Yeah, so let me quickly use this. Now you see that result that we have there, and I have only approximated it here. So let's do 5 raised to power that. And yeah, so you might be wondering why I used this underscore. So when you're working in Python, and this is also a trick that you possibly, I didn't talk about this. So, but if you're working in Python, it turns out that you can use the underscore to recall the previous answer that you had. So it's more like you recalling something from memory. And so you use the underscore, and that's just what I've done here. And of course I made a mistake there. So I think I would have to do, if I want to go that route, I would do 2/3 again. And then I would do 5 raised to power underscore, which is more like saying that 5 raised to power 0.666 and all that. And once I hit the enter button, I have this result. So what I've solved for now is this. And let me just write the answer here. 2.9240. And I'm just approximating to 4 decimal places. So once we do that, we then have minus 4. And let's see what we have. This minus 4. what do we have? We have negative 1.0. So negative 1.07598. And because we're dealing with floating points, the answer I have here, my variable, will definitely should be expecting to get the same, about the same thing. So let's run it and let's see. If I have not made any mistake anywhere, we should get this correctly. So 2 plus 3 raised to power 1 plus 2, 1 plus 2 divided by 3, then minus 4, and we get 10.62. So let me see where I have made a mistake. I am sure I have made a mistake somewhere. So let me just quickly check where I made that mistake. 2 plus 3 raised to power of this, 1 plus 2 divided by 3 minus 4. So we have 5, because we solved this first. 1 plus 2 divided by 3, 1 plus 2 divided by 3 gives us 1.66, and that's still correct up until this point. And so we do 5 raised to power 1.66. Let's see, 5 raised to power 1.66666666, whatever it is. So let's see, we have 14.0, and I think that's where I made a mistake. The fact that I didn't add this one to it, so that was where the mistake came from. And if we do that and then we subtract 4 from what we have there, we have 10.62, which is the correct answer. So that's what I expect. And as you can see, I myself made a mistake, because some of these things are things that, and it's a good practice when you make those mistakes. Making mistakes is not a problem. You need to enjoy debugging your codes. You need to enjoy walking through your code to know where the problem is from. And that's just an example of what I have done to resolve this problem. And that's why I would always advise that you try as much as possible to solve your questions by hand before you input them into Python to solve them for you. And that's all in this video. I just wanted to solve this exercise. And in the next video, we'll be taking a look at how to name variables, because we've talked about, if we look at this program, we had this item, we saw price, we saw payment, and I think in one of the videos, I mentioned that these are all variables. And what they do is that you store values inside them. And so we'll see how to name these variables, what sort of names we should give to our variables, and perhaps we'll take a look at the conventions as well. See you in the next one. Please don't forget to like, click the thumbs up button, and share this video and subscribe. And please, if you haven't, turn on your notification bell so that we can move along with this course. It promises to be an exciting one. So see you in the next one. Take care. Bye.